Hello. In this example, I want to determine whether the given number k is a zero of f of x. Now, a zero is a term that on the xy coordinate plane basically tells you for any of the x-intercepts here, it tells you the x-coordinate of the x-intercept, because an x-intercept is in the form of k comma 0. Now, what that tells me is that the function value at k must be 0. In other words, the y value must be 0. And because of the remainder theorem, that tells me that when I divide f of x by x minus k, k is a 0 when f of k is 0. Effectively, what I want to do is I want to take this k value, synthetically divide, and if my remainder is 0, then this value is a 0 of f of x. So let's look at A. Well, we have 1, and then we're going to synthetically divide using that 1. So our coefficients are 1, -4, 9, -6. Bring down the 1, multiply, add, multiply, add, multiply, and add. What this tells me is that f of 1 is equal to 0. In other words, the coordinate is 1, 0. Notice that because of this, that tells me that 1 is a 0 of this f of x. Therefore, on A, we get yes. Let's look at B. B, our k value is -1. Then we're going to have a 1, 0, 1, -3, 1. Bring down the 1, multiply, add, multiply, add, multiply, add, multiply, and add. Notice that this last number here is not 0. Because it's not 0, that tells me that no, f of -1 is not equal to 0. In fact, it is equal to 6 in this case. Let's look at letter C now. Letter C is a non-real complex number. I haven't said anywhere in here that I had to just use real numbers, real possible zeros. So I'm going to go ahead and do this using that 1 plus 2i. Now that gives me a 1, -2, 4, 2, -5. And I'm going to go ahead and change colors here just so you don't get too confused. So bring down the 1, and I'm going to multiply. 1 times anything is that anything, so I'm left with 1 plus 2i. Now notice that -2 plus 1 is -1, and then there's nothing here, so that's a 0i plus 2i is plus 2i. Now I can multiply 1 plus 2i times -1 plus 2i, and if you notice, that's going to give you -5. 4 times -5, excuse me one second. Okay, I've just included one thing here. I wanted you to see why this was -5. This is how you multiply 1 plus 2i times -1 plus 2i. You just FOIL this out. -1 plus 2i minus 2i plus 4i squared. This plus 4i squared is just -4. -4 minus 1 is -5. These two in the middle cancel. That's why I got the -5. 4 minus 5 is -1. -1 times this gives me -1 minus 2i. And 2 minus 1 is 1, 0 minus 2i is -2i. And 1 plus 2i times 1 minus 2i, if you FOIL it out again, will give you 5. and that's why I get 0 there. Now, that tells me that because this is 0, that 1 plus 2i is, let me just write it here, yes, it is a 0 of this function. There's one thing to keep in mind, however. Because I have 1 plus 2i as a 0, I immediately know, without a doubt, that there is a second 0, and it is the complex conjugate of whatever this is. So that means that 1 minus 2i is also a 0. By the way, this is why I like to do this upside down division symbol, because I can just keep going here and I can do the 1 minus 2i with the numbers that I got here. I don't have to go back to the original numbers. And you'll see why that's so helpful here in just a second. Now I'm going to go ahead and do this real quick. Of course, I'm going to do it in a different color. Bring down the 1, multiply, gives me 1 minus 2i, and you should notice that that gives me 0. 0 times anything is 0. Gives me negative 1. Multiply gives me negative 1 plus 2i. Whenever you add that, that gives me 0. That's proving that 1 minus 2i is also a 0 of this f of x.